In this video, we're going to look at completing the square. Some quadratic expressions can be factored as what we call perfect squares. If we take the quadratic expression x squared plus 10x plus 25, we could write this now as x plus 5 multiplied by x plus 5, which would give us x plus 5 all squared. This is a perfect square. We've got no constant on the outside, so it's not x plus 5 all squared plus 10 or minus 1. This is a perfect square. We could also look at other perfect squares. So 2x minus 1 all squared is a perfect square. If we had 5x plus 3 all squared, this is a perfect square. Not all quadratic expressions can be written as perfect squares. So for example, if we had x squared plus 4x plus 9, this can't be factored into a perfect square. What we're going to do in this video is look at using the completed square form. We can use the completed square form to solve equations, or we could even use it to find maximum and minimum points on the function. We'll start off with some basics. We will then go on to some harder examples, and then we will look at using them to graph. So let's start off. We're asked to complete the square for the following expressions given our answer in the form x plus p all squared plus q. So this is the completed square form. When we have examples when the coefficient of the term in x squared is 1, we can simply apply this particular approach. When we're completing the square, we need to ensure that the coefficient, so this number right here, is positive 1. What we're going to do is look at a really quite mechanical process of writing this expression in this form. What we do is set up now a set of brackets. We're going to take x, and then we consider now the term in x. We take half the coefficient of the term in x with its sign. So in this particular case, I need to take half of 4, which is going to be 2, and it will be plus 2. We then square the bracket, and I'm going to subtract away this number squared. 2 squared is 4, so I need to subtract that, and then I'm going to add the 9 that was on the original expression. All we need to do is tidy this up, and we can say this is x plus 2 all squared, and then we're going to have plus 5. The value here of p is going to be positive 2, and the value of q is going to be equal to positive 5. So we've put that now in the form x plus p all squared plus q, and we've completed the square. Let's just go ahead now and see what this looks like in terms of a quadratic graph. We start off now with y is equal to x squared. So if I take y is equal to x squared, it looks something like so. The vertex, or this minimum point, as it's positive, is at the origin, which is 0, 0. All this is two graph transformations. The first one is the f of x minus a, and the second one is the f of x plus a. These are just translations. Remember, this is going to give us a0, and this now is going to give us 0a. So in this particular case, we can see that we're going to have now a vector translation of negative 2, 5. So all that happens is we move now left by 2 and up by 5, and we can redraw the quadratic. So if I did that, move left by 2 and up by 5, this quadratic would look something like so. So we'd have the same shape, we've just moved it 2 to the left and 5 up. So we would say this is negative 2, positive 5. We will look at this more as we go, but I think that's a nice way of looking at it. So this now is the completed square form, and this is what happens to the graph as a result. So if we now look at the next one, we've got x squared minus 5x plus 3. This time, when we halve 5, we're not going to get an integer or whole number answer. We generally work using fractions. So I'm going to write this now as x I'm going to have minus 5 over 2. I'm not going to write minus 2.5. We square the bracket. So all I've done is taken x plus half the coefficient. We now need to subtract away this number squared. So 5 squared is 25, then we've got 2 squared, which is 4, and I need to add 3 back on. We can write this now in completed square form as x minus 5 over 2 all squared, and I'm just going to write this as 12 over 4, just combining the fractions. That's going to give me now minus 13 over 4. So all I've done is just added these. So we can see that the value of p in this particular case is negative 5 over 2. The value of q is going to be equal to negative 13 over 4. So if you wanted to think about this one, it's moved to the right by 2.5 and down by 13 over 4. So if we did that, we could go ahead and sketch out. So it's gone right by 2.5 and down by 13 over 4, which is going to be somewhere here. And we would end up now with the quadratic, and it would look like so. So if we go ahead and do that, the quadratic will do something like that. So that's what the completed square form can allow us to do. We'll spend more time looking at this later. Let's put this on. That's going to be on here 5 over 2, positive 5 over 2, negative 13 over 4. So if you simply want the basics, completing the square is this mechanical process. So if we quickly do one more, I'll just take a quadratic expression. All I've done is extended it on a little and looked at what would happen to the graphs. So let's say we've got x squared plus 8x minus 3. Well, we're going to take half the coefficient, so it'll be x plus the 4. We need to square the bracket. We need to subtract away the 4 squared, which is going to give me minus 16. And then we need to subtract away now the 3. So x plus 4 all squared, that is the perfect square part of this. And then the constant is now the negative 19, or if you like, you're subtracting 19. So in this particular case, p would be equal now to positive 4 and q would be equal to negative 19. Let's move on. We're asked to complete the square for the following expressions, given our answer in the form p multiplied by x plus q all squared plus r. When we're completing the square, we need to ensure that the coefficient, so the number in front of the x squared, is positive 1. If it's not, we look to factor it out. So let's go ahead and deal with this one right here. I think it's important to stress at this point, if we were solving an equation, then I would simply divide this equation, when it becomes an equation, by 2. But if we're asked to complete the square, we need to ensure that we're keeping the 2 there. We can't just go and divide it. So what I'm going to do is just write this now as 2x squared minus 6x, and then I'm just going to put plus 7 way out here. I'm going to take now the 2 out of this part right here and set up square brackets. So that leaves me now x squared minus 3x. I'm then going to close the square brackets, and the 7 is going to be left on the outside. I'm now going to complete the square on this expression inside the brackets. We can now do this as we have now the coefficient, the number here of the term x squared is 1. So if we do that inside the brackets, we're going to have now x minus half the coefficient, which is 3 over 2. We square the bracket, and I subtract away this number squared, which is minus 9 over 4. I close the bracket, and then I add back the 7. I'm now going to multiply through by the 2, and that will give me 2 lots of x minus 3 over 2, all squared, minus 9 over 2, if I multiply this by 2, and then I'm going to have plus the 7. So all I'm doing is bringing back the 7 afterwards. So if we wanted to combine now the fractions, we've got 2 lots of x minus 3 over 2, all squared. This is going to give me 14 over 2. 14 over 2 minus 9 over 2 will give me plus 5 over 2. So that now is in the form we want. The value of p is going to be positive 2. the value of q is going to be negative 3 over 2, and the value of r is going to be positive 5 over 2. So we've gone ahead and put that in the form as required. So as we can see, it's slightly harder, but we take that out. Okay, let's look at the next one. This one isn't in the form ax squared plus bx plus c. So what I'm going to do is rearrange that. We want the x squared, then the x, then the no x, or constant. So we have negative x squared plus 7x, and then we're going to have plus the 3. I need to factor out this negative. So if you want, you can write it as negative 1 or just negative. I'm only going to consider the first two terms. That will give me x squared, then we're going to have minus 7x. I'm going to leave the 3 outside. So if we multiply back through, we'd have negative x squared plus 7x. I'm now going to complete the square on the expression inside the bracket. And again, we've got now an odd number, which always makes it slightly nastier. 7 over 2. We square this. I'm now going to subtract away 7 squared, which is 49, over 2 squared, which is 4. I'm then going to close the brackets, and I'll bring back the 3. Multiplying through by the negative 1, we've got negative the quantity x minus 7 over 2, all squared, plus 2 negatives gives a positive 49 over 4, plus the 3. So plus the 3. So if I wanted to write 3 as now a fraction over 4, it would be 12. So we're going to get now negative the quantity x minus 7 over 2, all squared, plus, so that's going to be 12, so that will give me 61 over 4. So what we have now is the value of p is going to be negative 1, the value of q is going to be negative 7 over 2, and the value of r is going to be positive 61 over 4, and I'm leaving these as exact fractions. If we wanted to graph either of these, this one right here would be positive, as it's now got a positive quadratic. We got 2 instead of negative 2, so we would have a minimum. This one is a negative quadratic, so it'd open downwards, and we would have a maximum. So this is a max, and this is going to be a minimum. If we wanted to write down the coordinates of those, we could see now that the coordinates are going to be 3 over 2, comma 5 over 2 for the minimum. And if we wanted to look at the maximum here, we could say they would be 7 over 2, comma 61 over 4. All I'm doing is simply using now this value, and we have, well, essentially this is negative b over 2a, if you like, this value right here, which we will look at shortly, and that gives us the value here. And we'll look at something called the axis of symmetry as we go. So completing the square when the coefficient is not positive 1. Okay, let's move on. So far we've been putting it in this form, p, x plus q all squared plus r. I've just been doing this part for some additional sort of learning as such, but if you're simply asked to write the expression, this is all we need to do. Okay, let's look at this one now. We're asked to solve the following equations by completing the square, leaving your answers as exact values. When we're talking about exact values, we mean as surds generally. So instead of giving it to 2 or 3 decimal places, we just give a surd answer. So this one right here, it's in the form ax squared plus bx plus c is equal to 0. This is perfect. So all we need to do is go ahead and complete the square. So if we start off, x squared plus 2x minus 5 is equal to 0. At this point, some people might just say, well, x squared plus 2x is equal to 5, and then go ahead and complete the square on this part. I generally leave it here for now, as it just makes sense in terms of if we were just writing this as an expression. But either way around, it doesn't matter. So let's complete the square. What we're going to have is x plus half the coefficient, which is positive 1. We square the bracket. I'm going to subtract away the 1 squared. I've got now minus the other 5, and that's equal to 0. So we can write this now, adding the 5 and 1 to both sides. We're going to have x squared, x plus 1 all squared is equal to positive 6. At this stage, we take the square root of both sides, so x plus 1 will be equal to plus or minus the square root of 6, which is a surd value, or exact value. We subtract 1 from both sides, so we have x is negative 1 plus or minus the square root of 6. So negative 1 plus root 6, negative 1 minus root 6. If we wanted to sketch this, let's say we were asked to quickly sketch this, what we're going to have are two real solutions. We're going to have negative 1 plus the root of 6. So the root of 6 is going to be just, well, it's 2 and a bit. So let's put negative 1 plus 2 and a bit, which we're going to have here. And we would write it now as negative 1 plus root 6, comma 0, because we're solving, remember, when y is 0. And then the other one would be negative 1 minus the root 6, comma 0. And that would be just here. We could, of course, put the point of intersection with the coordinate axis, and that is where x is going to be 0 for the y-axis, so that would be somewhere down here. And let's just go ahead and do that. We could go ahead and then just sketch this up. So what we'd have is the quadratic. We know the quadratic opens up like so. We will have a minimum point down here. We'll have now our axis of symmetry, we will look at shortly, and then it'll come down like so. So this point right here is going to be 0, negative 5. So that is roughly, give or take, what the quadratic would look like if we were asked to now sketch y is equal to x squared plus 2x minus 5. All we're asked to do is find the solutions in exact form. They are just here. I've just gone ahead and graphed them for completeness. Okay, let's look at the next one. Now, with this one, we're solving an equation. When we're solving an equation compared to writing an expression, we can do something slightly different. As we saw here, I needed to keep the 2. I factored it. When we've got an equation, this one's set to 0, I can simply divide both sides by 2. That's going to give me x squared minus 3x plus 1/2 is equal to 0. So I'm just going to write this because it's a lot easier to complete the square when the coefficient of the term in x squared is positive 1. So if this was negative 2x squared, I would add it to both sides and divide by 2, or if you like, divide both sides by negative 2. So I've divided the whole equation here. So let's go ahead and complete the square. X minus 3 over 2, we're just taking half the coefficient. We square the bracket, subtracting away, 3 squared is 9, 2 squared is 4, plus the 1/2, and that is equal to 0. So I've got x minus 3 over 2, all squared, and if I just write this now as positive 2/4, 2/4 minus 9/4 is going to give me now 7/4, and that will be negative. That's equal to 0. We can add the 7/4 to both sides, so x minus 3 over 2, all squared is equal to 7 over 4. I think it's important right now to stress if you get a negative number at this stage on the right hand side of the equation will have no real roots, as we can't take the square root of a negative number and get real values. So if this was negative now, we would have no real roots, and we could see that from the graph anyway, because we'd have the minimum point at 3 over 2, comma, on here now, the negative, it would be positive in that case, 7 over 4. So let's go ahead and write this. So x minus 3 over 2, we need to square root both sides. So plus or minus the square root of 7 over 4. I'm going to add the 3 over 2 to both sides. And then I'm going to write plus or minus, and we can split this up. This is the same as square root of 7 over the square root of 4. The square root of 4 is 2, and that will correspond to the value we have here. So x is going to be equal to 3 plus or minus the square root of 7 over 2. And that is what we call an exact answer. So that's what we've got, and we could go ahead and graph that if we wanted. So if we think about this now, I could have used the quadratic equation. If I'd used the quadratic equation, we know the solutions. X will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we think a in this particular case would be 2, b would be equal to negative 6, and c would be equal to positive 1. So if I just simply substitute this into a calculator, we will get the same answers. So using the quadratic equation, which I was given in an exam, negative 6, so we're going to have 6. We'll take the positive first, then we're going to have negative 6, and again you could write just 6 squared, minus 4 times by a, which is 2, times by c, divided now by 2 lots of a, which is going to give me 4, and that will give us the 3 plus the root 7 over 2. If we swap that over, 3 minus the root 7 over 2, and that's exactly what we've got just here, 3 plus or minus root 7 over 2. If you wanted to give decimal answers, then we can say now it's 0.177 for the negative one, and then for the positive one it's going to be now 2.82, and so on and so forth. So that is looking at completing the square to solve equations. Of course, if it factors, go ahead and factor it. So let's just get a quick confidence boost. Let's say we were asked to now solve the equation. Let's say we've got x squared, and I'll make this slightly harder. Let's say we've got x squared, then we've got now, and we'll go for plus 2x is going to be equal to 8. So let's say we were asked to solve this equation first by factoring and then by completing the square. So I want this in the form ax squared plus bx plus c is equal to 0. So we could say now that x squared plus 2x minus the 8 is equal to 0. So two numbers that multiply to give negative 8 and add to give 2, that's going to give me x plus 4, x minus 2, that will be equal to 0. So we can say that x would be equal to negative 4 or x would be equal to 2. So there we go, nice and logical. So we've got those two solutions and we know we can factor it. If we were to complete the square, all I would do is complete the square on the left hand side. So it'd be x plus half the coefficient, which is 1. We would square the bracket and we would subtract away the 1. I'm going to leave the 8 over there because I'd have to take it over there anyway. I'm going to add the 1 to both sides, so x plus 1 all squared is equal to 9. Taking the square root, x plus 1 is going to be equal to plus or minus the square root of 9. So x plus 1 is equal to plus or minus 3. So x is going to be equal to negative 1 plus or minus 3. So we can see now that if we've got negative 1 plus 3, well, that's going to give me positive 2. Negative 1 minus 3 is going to give me negative 4. And as expected, exactly the same solutions. So this is in completed square form. So you might say to yourself, well, what's the advantage of completed square form? Well, we can use completed square form, certainly if the quadratic doesn't factor, but also if we picked it up at this stage right here, and we have the graph of y is equal to x plus 1 all squared minus 9, we would have now our graph to draw, and it would be easier because what we would have now is the following. If we went ahead, our axis of symmetry is going to be the line x is equal to negative 1, and we're going to look at that shortly. So we've got this point just here, and I'm going to put it just here. This is going to be the point now, negative 1 comma negative 9. We know that we have a solution just here at negative 4, and we have one just here at 2, and we could draw the graph like so. So we come round, and it would look something like that. So from this, we can see on here we've got additional information. So if we put here, this is going to be negative 4, 0. This is going to be 2, 0. We know the point of intersection with the y-axis is when x is going to be equal to 0. So that would be now 0, comma, negative 8. So at this stage, we've got quite a lot of information about this. If I wanted, I could put on my axis of symmetry. Remember, the axis of symmetry for the standard parabola, y is equal to x squared, is the y-axis. But of course, we've moved this now 1 to the left. In general, and I'll just write this on, this is going to be x. So x is going to be equal now to negative 1. That's the axis of symmetry. In general, the axis of symmetry is going to be negative b over 2a when you have the quadratic in the form ax squared plus bx plus c. So if we look at this one right here, it would be now negative b over 2a. So it would be negative 6 over 2 lots of the 2, which is going to give us 4. And we can see now that that will give us the point positive 3 over 2. So I suppose that's a bit beyond the scope of what we're looking at, but interesting nonetheless. So there we go, that's solving equations. We were simply asked to solve -1 plus or minus root 6, and then we had, now I wrote it like so, 3 plus or minus root 7 over 2. Now, if we were to graph this as well, I wouldn't divide through. I would simply go ahead and keep my 2, because that's going to give us, if we have 2 on the outside, a scale factor stretch in the y direction. Okay, we're asked to sketch the following curve stating the maximum or minimum points and writing the equation of the axis of symmetry. So let's look at the first one. So let's go ahead and do this. Y is going to be equal to x plus 3. So I've taken half the coefficient. I'm going to square that. I'm going to subtract away 3 squared, and then I'm going to subtract away the existing 5. So we can write this now as y is equal to x plus 3 all squared, and then we're going to have minus 14. So that's what I have. So I can go ahead with my sketch and just draw this up. So this is a standard parabola. It's a quadratic equation. Coefficient of the term in x squared is 1. It's positive, so it'll open upwards, and we will have the minimum point at -3, -14. We've moved 3 to the left and we've moved 14 down, and that's going to be the point just here. So now this is going to be -3, -14. Remember, the completed square form helps us with this basic graph transformation. So what I'm going to have is the following. If I consider now when x is equal to 0, y is going to be equal to -5. So that's going to be the point just here, 0, -5. We're simply sketching. We're not drawing some accurate diagram or accurate plot. What we're going to end up with is the parabola. The parabola will open upwards and it will look something like that, come back through and do that. That is a very rough sketch. We've got this minimum point, and it's a minimum because it's positive, so that's the minimum. If it was the other way around, it would be a maximum. We can put now the axis of symmetry on here. So if I put the axis of symmetry, that is the line x is equal to -3. So it's symmetric about that point. The distance from here to here, it's the same as the distance from here to here. So that gives us now the axis of symmetry. And then, of course, if we wanted to find the solutions to the equation, let's just write this in, x is equal to -3, we could find these points of intersection with the x-axis, and that is when y is going to be equal to 0. So we can pick it up at this stage, and we could say now that 0 is equal to the x plus 3 all squared minus 14. So adding 14 to both sides, that's going to be equal to x plus 3 all squared. Square root in both sides, plus or minus the square root of 14 is equal to x plus 3. And then finally subtracting 3 from both sides, -3 plus or minus root 14 is going to give us the value of x. We can't break this down any further as it's a simplified surd. So if we think the root of 16 is about is 4, the root of 9 is 3, so this is going to be 4 and a bit closer, 3 and a bit closer to 4 than it is 3. So I'm going to put now that this one right here is -3 plus the root 14, 0, and this one right here is -3 minus the root 14, 0. So that's all of the information that we would need on that particular graph. Let's now look at this one right here. So it's in the form ax squared plus bx plus c, and we need to complete the square for this one. We can't go ahead and just divide this by 3, as we've got a scale factor stretch of 3 in the y direction. So with this one, when we put it in the form p, the quantity x plus r all squared plus q, we're going to have 3 on the outside. So let's go ahead and do that. So first thing I'm going to do is write that y is equal to 3x squared minus 2x plus 1. So just focusing on this bit, what I'm going to do is take now the 3 out. So y is going to be equal to 3. Then we're going to have now x squared, and we're going to have now minus, and this is going to give me minus 2 over 3x, and then we're going to have the 1 left here. So let's complete the square here. So what we'll have is y is equal to 3 lots. Completing the square, I take x plus half the coefficient. So that's going to be minus 1/3. We square the bracket and subtract away this number squared, which is going to give me now minus 1/9. We are then going to go ahead and add the 1 back. So I've taken half the coefficient, I've squared it. I'm now going to multiply it back through by the 3. That's going to give me 3 lots of x minus 1/3 all squared. Then 3 times by negative 1/9 is going to be negative 1/3, and I'm going to add the 1 back. So what does that leave me with? Just tidying this up. We can say now that y is going to be equal to 3 lots of x minus 1/3 all squared, and then we're going to have, this is going to give me plus 2/3. So this is what we end up with. So with this one now, we could go ahead and sketch this. So a bit harder on this one. Let's just put on, we'll go for white one. Let's put on the white axis. With this one, if we think about this as a graph transformation, I'm going to put it as a graph transformation, we've moved across now by 1/3 and up by 2/3. So we can say now that the minimum point here, so we go across 1/3 and up 2/3, it's going to be just there. So if we go ahead and do that, we can put that this is going to be the point 1/3, 2/3. The nice thing about this is that I don't have to solve it for any points of intersection, as it's got no real roots. And we'll see why it's got no real roots shortly. So now I've just moved it across. If we think now, this is a y-axis. Where's it going to cross the y-axis? Well, that's when x is 0. So it's going to be the point just here, and that's going to be 0, 1. So 0, 1 is just there. It's going to open upwards as it's positive, and it will also have a scale factor stretch of 3. So this is going to be tighter to the y-axis than our standard y is equal to x squared parabola. And it'll look something like so. So that is a rough sketch. We can see that there are going to be no points of intersection with the coordinate axis. We can put the axis of symmetry on. We know that the axis of symmetry is going to be just here, and it's negative b over 2a, or if you like, you can just see now that axis is going to be the value positive 1/3. So x is going to be equal to positive 1/3. So if we think negative b over 2a just here is going to give us that value. So why do we have no solutions? Well, let's look at this. If I subtracted 2/3 from both sides, we'd have negative 2/3 is going to be equal to 3 lots of x minus 1/3 all squared. If I divide both sides by 3, we're going to have negative 2/9 is going to be equal to x minus 1/3 all squared. I can't at this stage take the square root of a negative number and get a real value. So this would have no real solutions. So no real solutions. And if we went ahead and put this into the quadratic equation with a equal to 3, b equal to negative 2, and c equal to positive 1, we would see it didn't. So that gives us some idea. So that's roughly what we would have with our sketch. Okay, let's look at this one right here. Y is equal to 3 minus x squared plus 7x. So y is equal to 3 minus x squared plus 7x. So I'll rewrite this now as y is equal to negative x squared plus 7x plus 3. This is now in the form ax squared plus bx plus c. This is a negative quadratic. Both of these have been positive, they've opened upwards, and they've had a minimum point. The minimum point here was negative 3, negative 14. This one right here was 1/3, 2/3, and then we're going to have on this one a maximum as it will open up downwards. So let's go ahead now and write this on. So we're going to take out the negative. So I'm going to have negative, I will have x squared, then I'll have minus 7x, and I will add the 3 on. So completing the square inside the square brackets, let's just put in there, we're going to have x minus 7/2 all squared. We need to subtract this number away, which is going to give me 49/4. I close the brackets, and then I'm going to add the 3. You can, of course, write 3 as, if we wanted, in terms of 12ths. In terms of fourths, we could write that as 12 over 4. Entirely up to you. So y is going to be equal to, multiplying the negative back through, we're going to have negative x minus 7 over 2 all squared. We're going to have now plus the 49 over 4. We've got two negatives, plus now the 61 over 4. And this is one that we looked at before. So if we look at this now, y is going to be equal now to negative, then we're going to have x minus 7 over 2 all squared, plus now that's going to let's just put the 12 over 4. I've already added it in my head, plus 12 over 4, which is going to give us plus the 61 over 4. So if we wanted to go ahead and sketch this, let's go ahead and do that. So this time, and let's change it over to the white one. Let's do that. Let's go down here. We can now sketch this up. So this is going to be a negative parabola. We're going to have now our maximum point at 7 over 2, which is 3.5, and then 61 over 4, which is about 15 and a quarter. So let's put it just here. So this point is going to be 7 over 2, comma, 61 over 4. So a rough idea, that's not brilliant, but it just gives us some idea. Remember, this is just a sketch. I'm not doing anything crazy. Now, with this one, we know it's going to cross the y-axis when x is equal to 0. So that will be the point just here. And that is going to be on there, and I'll put that just there. That is going to be 0, 3. So what we'll have is the parabola, and the parabola will open now like so, and round like so. So that now is the maximum point. And this is just some idea. So this we can write on as our maximum. Our axis of symmetry, so the equation of that line is just here, and that is the line x is equal to 7 over 2. So let's put this on, x is equal to 7 over 2, axis of symmetry. Maximum point, and we'll write on that is a max. We can write on that these are mins, let's just put min, so min. So if this was, for example, a velocity function, the minimum velocity would occur here. Well, we'll look at this one, in fact, for positive values of time, the minimum value of the velocity would be here. If this was a velocity, the maximum velocity would occur just here. So what can we do now? We've got these on. Well, we could go ahead and look at finding the points of intersection. So this is the x-axis, and this is where y is going to be equal to 0. So we could say that 0 was equal to negative the quantity x minus 7 over 2 all squared plus 61 over 4. If I add this quantity to both sides, we've got x minus 7 over 2 all squared is equal to 61 over 4. Taking the square root of both sides of the equation, x minus 7 over 2 is equal to plus or minus the square root of 61 over 4. Adding the 7 over 2 to both sides, x is equal to 7 over 2 plus or minus the root of 61, which I don't think is, well, it's not going to break down, divided by the square root of 4, which is 2. So x is going to be equal to 7 plus or minus the root of 61 over 2. So this one right here is going to be 7. So 7 plus now root 61 over 2. And this is going to be 7 minus the root 61 over 2. And both those, of course, are common at 0. So we've gone ahead and drawn those up. So nice, as I say, this is fairly decent level stuff at this stage when we're expected to graph and find points of intersection and draw a sketch. Remember, it's just a sketch. It's not meant to be wildly accurate, and as we can see from that, that's not wildly accurate, but it gives the main features of the function. Okay, let's finish off. We've done those ones. Let's just finish off with one last thing. The quadratic equation. Now, if we consider that x is equal to now negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to have is the following. This gives us the solutions now to the equation when we have an equation in the form ax squared plus bx plus c is equal to 0. So if we want to find the solutions to this equation, we can use the quadratic equation. So what I'm going to do now here is really as a bit of an extension, but it kind of shows where the completed square form comes in. What I'm going to do is complete the square on this expression to show that the roots of a quadratic in this form give us the quadratic equation. So as stated, bit of extension. I doubt you're going to be asked to do this. What I'm going to do at this stage is divide both sides of the equation by a. That's going to give me x squared plus b divided by a, x, plus c divided by a is equal to 0. So if this was 2x squared dividing through by 2. I'm now going to complete the square on this part right here. So just now for x and the x squared. So we have x plus half the coefficient. So half the coefficient is going to be b over 2a. We square the bracket and I'm going to subtract away this number squared, which is minus b squared, and we just have to be careful, this is going to be over 4a squared. Then I'm going to add now the c over a, and that will be equal to 0. At this stage, I'm going to now just write that x plus b over 2a all squared is going to be equal to, adding this to both sides, b squared over 4a squared minus now the c over a. I'm just at this stage going to rewrite this fraction, okay? So what we've got here is c over a. I'm going to square both sides, or the top and the bottom, and get a common denominator by multiplying it by 4. So what we're going to have is x plus b over 2a all squared. That's going to be equal to b squared over 4a squared. If I just consider now, I'm going to get now the common denominator. So I need to multiply this. To get 4a squared, I need to multiply this by 4a. So that's going to give me 4a squared. And I need to multiply this by 4a as well, which will give me 4ac. At this stage, I'm going to now combine these fractions. So x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. At this stage, I'm going to take the square root of both sides. So x plus b over 2a will be equal to plus or minus the square root now of, and just extending that, b squared minus 4ac all over 4a squared. I'm going to add this, or subtract it from both sides, I should say. So we've got negative b over 2a plus or minus the square root, and I'm going to split this up, b squared minus 4ac. If I take the square root of the denominator, the square root of the denominator is going to be 2a. All I need to do now is combine these, so we can say x is equal to negative b plus or minus the square root of b squared minus 4ac, and let's just have a look for ac, there we go, all under there, all over now 2a, and if we look, that is the quadratic equation. So we can see that we can actually derive the quadratic equation. I wouldn't expect you to be doing that in an exam, but I think it's impressive nonetheless. But when you think, well, where's the quadratic equation come from? Well, it's from completing the square. If we've got a quadratic equation in this form, so for example 2x squared plus 3x minus 14, that's the value of a, that's the value of b, that's the value of c. Any quadratic in this form set to 0, we can look to solve if it has real roots using this particular approach, and we can do that by completing the square. So there we go, completing the square. Completing the square can help us with maximum and minimum points. It can also allow us to solve equations.